the next speaker made Swinject and is Yoichi.
Hi, thank you for coming to my talk. And I'm going to talk about dependency injection today. And before talking about it, let me introduce myself. And my name is Yoichi, as introduced, and I'm from Tokyo. Like this picture. Yeah, I found the similarity between the Paris and Tokyo. It has a symbol by the tower. So I visited the Eiffel Tower the day before yesterday, and I pretty like it. And if you visit Tokyo, I recommend you to visit the Tokyo Tower and also this building, because I work here. Yeah, at a company called Mercari. It has a headquarters in Tokyo and London and Palo Alto. And as I introduced, I'm an author of Swinject, which is a dependency injection framework for Swift. And it is now maintained by 5 members, especially Jack Varno now. And it has more than 2,000 GitHub stars and 1,000 clones every day. And it also provides 4 extensions for convenience. Okay, so today I'm going to talk about first software architecture, then dependency injection. And at the end, I'm going to talk about the Swinject with some sample code. So first, what is software architecture? Yeah, a lot of people say this is software architecture, this is the definition of software architecture. So Peter Eeles, he gathered information and summarized the definition of architecture like this in this article. This article is already 10 years old, more than 10 years old, but still it's really worth reading it. So he says that an architecture defines structure and behavior, as you know, and it focuses on significant elements only, so not tiny part of the code, but big part the architecture has focused. And this is also probably, as you know. And also architecture may conform to an architecture style, like MVVM, MVV, or Viper, or maybe MVC. And also, architecture influences team structure. It is also known as the inverse Conway maneuver. And he said 3 important things and less known things as an architecture in the article. So which is the architecture balances the stakeholder needs, and architecture is influenced by its environment. And architecture embodies decision based on rational. So the architecture is really related to your team, or maybe yourself, your team members, or the customers or users, or business owners, and also maybe with the government with regulations. So the architecture should be chosen with its environment. And also it often changes as time goes by. So you need decision to make the architecture for your system. So architecture is not static but dynamic over time. So this is an example. At the beginning of the launch of your application, and after 2 years, 5 years, and 8 years, how the users changes. At the beginning, you have no users usually. But after 2 years, you might have 10,000 users, and after 5 years, 10 million. And after 8 years, 100 million users you might have. How about engineers, number of engineers? At the beginning, the engineers like yourself only. But after 2 years, the team has 5 members. And after 5 years, the team might have 10 members. And after 8 years, you might have 100 engineers in the company. So in the environment, what can be a good architecture or just suggestion or option you can take? So first, you might choose MVC because it's really simple to develop and it's really fast to develop your application. And after 2 years, you might choose MVVM. And after 5 years, you might choose Viper to make separation of concerns in your system. And after 80 years, you might choose Uber Eats to make a big company engineers into separate smaller team to get them ownership to develop their features or application. So the architecture is not static but dynamic as time goes by. So let's say now you have this kind of system. The A part references B and it references C. But later, you might want to replace B part with completely new one. Or you want to split the C part into C1 or C2, two pieces. Or you maybe want to add completely new D part. And also, in the same way, you might want to do the similar things like this, production and a unit test. So in the production, you have the system ABC like this. And unit test, you might want to replace B and C with a mock or stub of B to test the A part. So we needed flexibility in the architecture. So how to make the architecture flexible? So here is a dependency injection. Because the dependency injection is glue, but it's really sticky like glue. So if you stick two pieces of things by just normal glue, like the left side of the picture, it's tight coupling. So it's really hard to replace the sticked parts, or it's really difficult to remove. But if you have sticky, it's loose coupling. It's really easy to replace with another sticky. Or you can just move one sticky to another part, or you can just easy to cut one sticky to two pieces. So how to make the sticky like glue in your system? So before talking about that, I'm going to introduce the solid principle. This is a famous one, and I think a lot of you guys know about this. And I'm not going to about detail of the first 4 principles, but here S means the single responsibility principle, and O means open close principle, and L is risk of substitution principle, and I is interface segregation principle. And here I want to talk about is dependency inversion principle, which means the system should not depend on the concretions but abstractions. So what does it mean, the dependent on concretion and abstractions? This is the example. So if you make the system dependent on concretion, it's like this picture. Your implementation references the concrete type. So it's like typical normal glue like this. But if you make a system dependent on abstraction, it's like this. So your implementation references just protocol or interface in another language than Swift. So in this case, it's really easy to replace the concrete type A with B. It's like sticky. But here we have problem that the system cannot work only with the protocol or abstraction. You need concretion or exact implementation for the protocol or interface to get the system work. So here, what you do is a dependency injection. It's a way to realize dependency inversion principle. And it is a really simple concept. What you need to do is just pass or inject an instance of concrete type to the initializer of your implementation. Then the system is configured like this. Okay, so code example is like this. So let's say you have the abstraction, which is the protocol, API client protocol. And also you have the concretion, it's API client conforming to the API client protocol. And the dependency injection is like this. So to make an instance of, for example, my view model here, you pass an instance of API client or inject concrete type to the abstract parameter here. And the exact implementation of the MyView model is like this. It has stored property to store the API client protocol. And also it has initializer that takes the dependency to get injected. Okay, the concept is really easy. So let's see the example using the dependency injection with the Swinject. So it's really easy to use, like dictionary. So the concept is like this. So you register the definition of the dependency into the container first. Then when you need an instance of a type, you call resolve method on the container. So the code example is like this. First import Swinject, then make a container instance. Then first you register the dependency like this. So in this example here, API client protocol will be resolved as an API client. The definition is made by the closure. And the next, you are going to define the dependency of MyView model like this. The closure takes a resolver. It's a kind of alias to the container that have only the resolve method. So here you take or you get API client from the resolver. And you don't have to care about the exact implementation of the API client, but you just get something that conforms to API client protocol. Then you pass the API client to the initializer of MyView model like this. So this is just simple definition of dependency. And when you need an instance of that type, MyView model, it's easy to get from the container like this. What you need to do is just call resolve method with the type MyView model. Then every dependencies are resolved to get the MyView model. So it's pretty easy, especially for simple case, but in a production app, often you have this kind of initializer if you have, or if you use dependency injection. It has so many dependencies, like here in the example, D1, D2, D3. And also, you need parameters to get instantiated the MyView model, for example, like this. In this example, parameters are ID and names. So it happens often in a production app. So how to solve the problem? So here is a good practice to solve the problem using the type alias of dependency tuple. So in this example, you make the type alias of tuple with D1, D2, D3, and pass the dependency, the type alias dependency to the initializer. And you pass the parameter as is like this, with ID and names. So in this way, it's really clear to see the left side is dependency, and right side is just parameter. So I'm going to show you how to make it by the code example. And to make it simple, the example has 2 dependencies and 1 parameter. So you have 2 protocols, like API client protocol and logger protocol, and their implementation conforming to those protocols. And here is the definition of my view model using type alias of tuple. So here, you define the type alias with the API client protocol and logger protocol to bundle the dependency. And you have those stored properties to store the dependency and also parameter. And initializer is just like this to get the dependency and the parameter injected. So here is the registration of the dependency definition. So first, you register the 2 protocols with the closure to tell what should be the actual implementation of the protocol. And here is the registration of the dependencies on the MyView model. So as you see, it has dependency protocol with the 2 dependencies, API client protocol and logger protocol. And here, you pass the dependency tuple and ID parameter from the closure to the initializer of MyView model. So when you need an instance from the container, it's easy to use. It's easy to call just resolve method with the type MyView model and the parameter. Okay, so it's really easy to see the dependency and the parameters with this practice. So let's add another dependency to implement new features. So in your production, it's often you see that you need to add more dependencies to a type as you develop the app. So this is the way to do it. So first, let's say we want to add database protocol and its implementation, database. And what you need to do is add the dependency to the tuple. So now, the dependency tuple has 3 elements. And what you see here is this. It's error told by compiler, so wrong tuple here. So what you need to do is add database parameter here as an element of the tuple. And also you need to add the database parameter to the tuple here too in the initializer. Then you get the error disappear. And next, what you need to do is here, you get the compiler error like this, cannot convert something blah, blah, blah at the MyView model initializer. Then what you need to do here is first register the dependency. Actually, how the database protocol is resolved as a concrete type. And also you need to add the resolution from the resolver to the dependency here. So now the dependency parameter has 3 elements. And you get the error disappear. So using this practice with the swinject, it just follow what compiler says to add new dependencies as you keep developing your application. Okay, this is a summary. So first, architecture is not static, but dynamic as time goes by. And dependency injection is sticky like glue. And use the typealias to group dependencies. It's really good practice. And just follow Swift compiler to add new dependencies. Okay, here is more information about the dependency injection and swinject if you want to know more. And I'm going to make the slides public later. Thank you very much. Merci beaucoup.
Thank you.